All right, guys, in this quick video, we're going to do the FRQ style questions on this review. They both have to do with logistical growth. Number 17, calculator active, says the population of elephants in a wildlife preserve increases according to the logistical function E of t is equal to 80 over 1 plus 3 e to the negative 2.5 t, where t is measured in years. How many elephants were originally in the preserve? So I want you to know, the main thing I want you to remember is that this logistical growth, this population growth, if there's a logistical, it grows slowly and then really fast and then slows off and levels off. This point up here is called the limiting value or the carrying capacity. We call that L. And if we have the derivative, the differential equation, something like d, I guess this one would be elephants, dE dt is equal to some number, I guess it would be like 0.25 e, and then 1 minus e over, this one would be 80. So I can look at this and know the limiting number is 80 because as like time moves on, the slope, the derivative, which is the differential equation, approaches 0 because this part right here approaches 0. If this was 80, this would be 80 over 80, which is like basically 1. 1 minus 1 is 0. Anyways, this question says how many elephants were originally in the preserve? So to find that, this is the function that gives you the number of elephants with relation to time. So just plug in 0 for time. I get 80 over 1 plus 3 e to some exponent of 0. This would just be 80 over 4, which is 20. So 20 elephants. How many elephants can the preserve maintain? Which would be 80. Kind of know that is the 80 number. But we could also say the limit as t approaches infinity of 80 over 1 plus 3 e to the negative 0.25 t. As t goes to infinity, what's happening? So as t approaches infinity, let's see, this would be a huge negative number, right? Because a huge number times negative 0.25, this would be like 80 over, okay, this is bad notation. This is a limit idea. 1 plus 3 to 1 over e to the positive infinity. To get rid of the negative infinity, make it like a fraction. This is basically 0, so that's 0, so it would just be 80. So if you didn't know, just think about like what's the limiting value, find the limit as t goes to infinity. It's going to wind up being that top number up there. At what time is the elephant population growing the most rapidly? Okay, we know this logistical growth, if the limiting value is up here, the population growth rate is the maximum halfway up. So if the limiting capacity is 80, halfway up would be 40. But that's when oh, I almost messed this up. So this is if the population would be 40 elephants. But it wants to know at what time did that happen? Okay, I need to get Desmos open. Almost messed this up. This would be 80 on top. Okay, I'm graphing this. I'm gonna set it equal, and then I'm also gonna graph y equals 40. And I'm gonna see where they intersect. Y equals 40. Sorry, I should have been more prepared. 1, 2, 3. I'll just fast forward till I get the answer. All right, so I'm looking at my graph. Y equals 40. Got the intersection point on Desmos. T is 4.39445. All right, calculator active on number 18. This time they give you a differential equation, and I didn't type in the p that I should have here. dp over dt should be 6.5p. 1 minus p over 200. So this time they give you the slope at different values for p. Okay, this is the format. When I've got like a p out here and a p inside that, they're like counteracting each other. That's that gives us that differential equation for a logistical growth model. That's kind of what you want to see. Okay, find the size of the population of the iPhone 15 owners at t equals 0.5. Okay, the other thing I don't think you need to memorize is that the general equation, this would be P of t, is equal to L over 1 plus B e to the negative kt. And in this case, the K is 6.5 and the L is 200, the living capacity. 6.5, 0.65. T. But I still need to find B, and in order to find B, it tells me at time 0, there are 1 million iPhone 15 owners. So that's in millions, so just be careful. So I'm gonna plug in plug in 0 for T. What am I doing here? Let's move this over here. So I'm gonna say 1 is equal to, and then plug in 0 for the T. The nice thing is that wipes this whole part out. That's just 1. So 1 is equal to 200 over 1 plus B. So B is 199. So now I've got all my information to actually make the equation. K is 6.5, so negative 6.5 T. So I want to find the population of iPhone 15 owners when time is 0.5. So plug in 0.5 for this T. And I would use Desmos calculator active, and I get 22.94613. And make sure you say million people. Don't just say people, say million people, because the units are in millions. Okay, find the time when the population of the new iPhone reaches 197 million. So what I would do is plug this whole equation in to Desmos. So I'd say y equals 200 over 1 plus 199 e to the negative 6.5x. And I'd say y equals 197. I find where they intersect. The time value of 1.45814 years. All right, that's a quick little review. Hopefully it helped you and makes sense. And thank you for watching. Bye.